Okay, we are going to go over our symmetry homework. So for our very first part here, looking at this, there's no need to go through all the tests. What you need to do is see if you can't figure out just from looking at it which of the symmetry this would be. So from here, looking at this, it looks like we might be symmetrical about the origin here. Notice that it does look like we could fold this over or rotate it 180 degrees, and we would have the same graph. So probably have the origin. Now the test for that is we need to substitute in both a negative y and a negative x. And when we work through that, notice we have negative y equals negative 1/4 x cubed. And if we simplify those negatives, we do get back the original function. Okay, number 2. Again, looking at this, if we were to rotate this graph 180 degrees and from here around to here, then it looks like we're going to have the same exact graph again. So this looks an awful lot like the origin. So let's go ahead and substitute in a negative x and a negative y. And notice when I find their product, that does generate the original equation back again. So this would be symmetric about the origin. Number 3, looks like here we have mirror images across the y-axis. So this looks like it is symmetric about the y. And so going through here, if we're symmetric about the y-axis, we need to replace the x with a negative x. And notice working this out, we're going to have the absolute value of negative 2x minus 5, and that will generate the same thing as what we have up here. So that did generate back our original, so definitely symmetric about the y-axis. On number 4, this one, it doesn't look like we're going to be symmetric about any of the origins. This one, or x or y axis. If I rotate this 180 degrees, it does not give us back the original. And it doesn't look like we're symmetric about the y. We don't have a mirror image. And then the x-axis is not a mirror image. So I think this one would be none. If we go through our tests, we could show through the tests. If we wanted to show we could not have about the y-axis, we would substitute in a negative y. And notice that does not give us our original. We could substitute in a negative x, and that's going to be the cube root of negative 2x, and we would be able to move the negative out, but that's definitely not going to be the same. And if we replace both of them, we are not going to be able to remove the negative because of the negative 3. So this one would be none. Number 5 looks like a great example of symmetric about the x-axis. Notice that these two across the x-axis are mirror images of each other. And to prove this, we would substitute in a negative y. And when I do this, I have y squared minus x equals 4, which does generate back our original function. So this is definitely symmetric about the x-axis. And number 6, notice this looks like it is symmetric about everything. With the circle, it would normally be, unless it's been moved away from the origin here. But notice that all 3 of these, you're symmetric about all 3. And I do want y'all just to show the origin since you are symmetric about all 3 of these. And when you substitute in your negative x and your negative y, notice once simplified, you do end up with your original function again. Okay, with these functions, we have to tell whether we have an even, odd, or neither. And so again, we're still looking at a type of symmetry about the origin or the y-axis. So The first thing we need to do every time, our first step would be to substitute in a negative x. And if we do that, we have to examine what we get after we simplify. And notice this one looks like it's going to generate back the same exact equation that we started with. And so here, notice we did get back the same. So this would be even, and you are symmetric about the y-axis. And again, that's because once we plugged in, we got back the original function. Now, number 10, we are still going to start. Our first step is always the same. You need to evaluate f at negative x, and that's going to give us negative x over 7, which is not the original, so we know it's not even. So then we go to our second step, and that is we need to find negative times f of x, which is going to be negative times x over 7. And notice this did generate our f at negative x. So therefore, we know this one is odd. And be careful, this is implying that we are symmetric about the origin. All right, so looking at number 11, this one we are going to again start by substituting in f at negative x, and that's going to be the square root of negative x minus 4, and there's nothing we can do with that. We can't factor out that negative or anything like that due to the radical, and that be able to simplify down to our original. We could try negative times f at x, but that's going to move this negative to the outside, which is still not what we started with. So this one would be neither. And if we look at number 12, this one, again, we're going to start with f at negative x. So that's going to be the absolute value of 5 times negative x minus 6. And notice that gives me the absolute value of negative 5x minus 6, which is still the same thing as the absolute value of 5x minus 6. So this one is even, and we are symmetric about the y-axis. Right, so number 13, again, we are going to do our first step, which is going to be f at negative x. And so we're going to have negative 4 times negative x raised to the 4th plus 9 times negative x all squared. When we simplify this, notice we do generate the original function back. And so this one then is going to be even. And this is also going to be symmetric about the y-axis. Okay, and number 14, if we substitute in here our negative x, this one looks like it's probably going to end up being neither because of our x when it's going on here. So that's 2 times negative x minus 5. And so we're going to have x squared minus 2x minus 5. That certainly doesn't match. And then if we evaluate negative f of x, then that's going to be a negative x squared, a minus 2x, and a positive 5. We're multiplying everything by negative 1. And still we're close, but we did not generate f at negative x, so this one would be neither. Right, number 15. Again, we are substituting in a negative x. And so if we do that, notice what we're going to get. F at negative x is going to be the absolute value of, that's going to end up being negative 2x minus 9. And we might want to go ahead and try to do the individual absolute value, but What we really need to do here to do this correctly is factor out the negative. And if we look at it from that point of view, notice we do not generate the original. And we're not going to if we go ahead and put the negative on the outside, because it still would be the negative times absolute value 2x minus 9. So this one would be neither. And number 16, we're going to go through here again. We're going to find f at negative x. And this is going to give us the cube root. Notice that is an odd root times negative x, and that's going to allow us to have negative 5x, and this negative here, if you want to think about it as negative 1 times 5x, then we can remove that negative out from under the radical, and so we have negative cube root of 5x, which is going to be what we get when we try to find negative times f of x. So this one does generate here and here, those are equal. So this one would be an odd function, and we are symmetric about the origin.